Hello friends, welcome to SahuStudies. In this video, I am going to discuss about reduce function in PySpark. So what is reduce function and why do we use reduce function? So reduce function is a aggregate function. It is used to calculate min, max, sum, etc. Right? Suppose there is a requirement to calculate the minimum value or a maximum value from a RDD or what is the sum. Then with the help of a reduce function, we can able to do because reduce function is an aggregate function. So to reduce the function, it is required to pass the type of argument as a parameter. It returns RDD and the type will be the same as the input RDD. This is very important, right? Suppose the input type is RDD, so the output type is also a RDD. It uses binary operator to reduce the element of input RDD. So whenever this reduce function will going to take action, it will going to use the binary operator to reduce the element of the input which is present in the RDD. Let's discuss the reduce function with the help of one of the pictorial representation. So suppose a Spark is, we all know a Spark is a distributed and it has nodes. Some are executors and one of them are driver. So suppose we have a data which is present in these three executors, and the data is these are the data which is present in the node 1, this is the data which is present in the node 2, and this is the data which is present in the node 3. So the function it will call, what is the function is value, it will add value 1 and value 2 till only one value will going to remain. Means first it will going to add this value. So whatever the result it will come, it will going to add with this value. Then what is the result it will come, it will going to add with this value. And what the result it will come, then it will going to add with this value. So each and every time it will going to pick two value, do the addition, and the final output be only one value. We can see here node 1 has value this one, node 2 has value this one, and node 3 has a value this one. Once we have all the value which is present in the different nodes, again the function value 1 and value 2 it will going to take place. So what it will going to do, first it will add these two value, whatever the result it will do, means this is the value 1, this is the value 2, and what is the result comes by the addition of this value and this value, it will going to be the value 1 and it will going to add two value here. So the result of these two addition would be value 1 and this is the value 2, and the final output would be this one. This is a typo. Actually, this is a 300. It should be. This is a typo. So in this way, reduce function generally works. So this function plays a very important role because it will going to take value 1 and value 2 and it will give the output. Again, the output of this function will become the value 1 and it will going to take the value 2 and same process it will do until it reaches only one value. So in this exercise, what I am going to do, I am just processing this data. I will going this is in the form of a list object. I will going to create a RDD with the help of this spark.context.parallelize, right? By passing this list variable. When this RDD will going to create, no, so what I am going to do, I am doing the reduce and passing this function. What is the function? This is already a predefined function which is present in operator, which I am just importing it from here from operator important. So what it will going to do, it will just whatever the sum of this value, it will going to print out. As I have mentioned that reduce is a aggregate. With the help of a reduce, we perform different kind of aggregates. So sum is one of the aggregates. So and another aggregate is the minimum value. Suppose we want to fetch what is the minimum value. So with the help of this function, we can able to get it what is the minimum value. So with the help of a lambda, I am just defining the function. This is the parameter one. This is the parameter two. AP smallest. It will going to be the value if it is less than from the AP current, and if it not less than the AP current value, it will going to fetch. It will going to be uh, of you can say it's a return type. And whenever we are going to print the value, so whatever the minimum value which is present from this or this list or from this RDD, it will going to fetch the smallest value. The same is from the largest. Okay, I am calling the reduce function on top of this RDD. With the help of a lambda function, I am creating a function. This is a two parameter which I am passing as a parameter. If it will it will return AP largest if AP largest is greater than AP current. If not, then AP current would be returned. And whenever we are just printing this variable, so whatever the value which is the maximum which is present in this RDD, that value will going to return. So let's do this exercise in Databricks. Let me create a notebook. Make it as a reduce, rename is a reduce function. To perform the reduce function, we need some data. So to save time, I have created a data set which is in the form of a list. Then I am running it. So wait till this list variable gets defined. What it is saying? Okay, sorry. This is a Scala. We need to use this Python. Let me run it again. Okay, this list variable has been defined successfully. Now let's create a RDD object. So how we are going to create the RDD object? We are going to create RDD object with the help of a spark context and then parallelize method. And in the parallelize method, we need to pass an object which contains the data. So this is the object which is containing the data. Now let's run it. Now this RDD object has been created successfully. Now let's import the add function. So how we are going to import from operator, import add. So this is a predefined function. I'm just going to import it. Now let's implement the reduce function on top of this RDD. And this RDD has which kind of a data? It has this kind of a data which is present in this list. Okay. So if you are going to use one aggregate function, that is the sum, it will going to add all those values and give a return type a single value. Right. So let me create a variable AP reduce sum, and how we are going to call this reduce. So this is the RDD on top of RDD. We need to call this reduce and pass this function that is add. Now run it. let's print this value. Print, run it. So this is the total output. What is the total output? Means sum of this, sum of the value which is present in this list. So total is 120. Right. Now let's figure it out. What is the minimum value which is present in this RDD? And what and how this RDD gets created? We have created with the help of this list variable. So now let's define one variable AP reduce underscore mean, and AP RDD. Let's call this reduce function, and in the reduce function what I am going to do, I am creating a function with the help of a lambda and passing two variable as an input. One is AP smallest and AP current, and we are saying that AP smallest return AP smallest if AP smallest is less than AP current, else AP current. Let's run it. Let make it in the bracket, otherwise no, it will confused. So let's run it again. Okay, so let's print this value. So what is the minimum value? It is 1. So we can see here in this list the minimum value is 1. We can able to figure it out from here also. But what I have done, let me just explain one more time. I am calling a reduce function on top of this RDD. With the help of this lambda, I am creating one function, and I am passing two parameters. One is AP smallest and one is AP current. So return AP smallest if AP smallest is less than AP current or less, or if not, then return AP current. So with the help of this function, it will going to evaluate all the value which is present in the RDD with the help of a reduce function, and it will going to give us the what is the minimum value which is present in this RDD. Now let's create another function for the AP to figure it out what is the maximum value. AP reduce max. So how we are going to do? On the AP RDD we are going to call AP reduce function, and in the AP reduce we are just defining one function with the help of a lambda and passing two parameter AP largest and AP current. AP return AP largest if AP largest is greater than AP current, else AP current. Run it. Now print this variable. So here we can see this is 100. We can also able to figure it out from this list object. 100 is the maximum one. So let's discuss one more time what I have done here. On top of RDD, I am just calling the reduce function, and in the reduce function I am creating one function with the help of a lambda. This function is taking two parameters, that is AP largest and AP current. Return AP largest if AP largest is greater than AP current. If not, then return AP current. So with the help of this function, Spark will going to evaluate all the value which is present in this RDD with the help of this reduce function and figure it out what is the maximum value. So here the maximum value is 100. So in this way we have seen here how we can use reduce function to do some kind of aggregation. Aggregation which we have seen here is addition, figuring out what is the minimum value, figuring out what is the maximum value. Let's go to the PPT. Thank you. If you like content of my video, then please subscribe my channel, like it, comment on it, and press the bell icon to get notification whenever I add videos.